we have a very, you can say, popular or very good process. It is called as the shell mold casting, and you prepare small gears in batches, and the accuracy and surface finish of such gears lies in between the sand casting and the investment casting. So if someone asks you that which process gives you the highest accuracy, then the answer is the investment casting. And if someone asks you that which process gives you the least accuracy or least surface finish, means which casting process, then the answer is the sand casting. And this process lies in between the range of sand casting and the investment casting. So in the first stage, what happens that you have a metallic which is filled with sand and a binder mixture, and then you place your heated pattern over this flask. And then in the second stage, you invert this flask like this. So what will happen? Then you allow it to settle down, and with the help of this heat and the shape of the pattern, some of the layer or the shell-like structure is formed on this heated pattern. So in this stage 3, it has solidified, and what you do, you take out this pattern which is having this shell with the coating like feature, and then you place it in the oven to properly cure the binder into this particular shell. And in the fifth is you shake out this pattern, so it loosen up the shell structure, and then you have a shell like half size. And in the sixth, which is the last stage, you take 2 shells of this size, and then you join together and place these shells into the mold cavity, which is filled with the sand or metal shots. So what are metal shots? Metal shots are basically tiny steel balls of the size of the sand and somewhat bigger size than sand. Then you make this structure, and then you have the die cavity, the cavity like this. And then in the seventh stage, you fill this die cavity with your molten material, and then you allow it to solidify for some time, and then you can say take out the structure from this flask. So this is the shell mold casting process. It gives small gears in the batches, and the accuracy of gears lies in between accuracy of sand casting and the investment. So this is a very brief discussion about the shell mold casting process. After, we have a rolling process. So if you remember that we have already studied the process of rolling in the thread manufacturing, that topic was discussed in the production technology 2 subject. And you know that this rolling is basically the process of plastic deformation, and then you have hard dies, flat or circular dies. So the same way in which you manufacture the threads, the similar way you manufacture the gear in this process. So the external steel gears, mainly in the straight or helical teeth of small to medium size, are produced with the help of this process, and then these steels are formed by cold rolling. So cold rolling is a deformation process. As you can see in this figure, that you have a gear blank. You have a blank which does not have any kind of teeth, and then you roll this gear blank under this moving dies. So the dies can be flat dies, which are known as rack type, and sometimes you have circular dies like this. You can say external gears or splines can easily be formed on the shaft, and this is a process which gives you gears of very high finish. And as you know that you are not removing any kind of material from your raw material, so the teeth produced by this, or you can say the gears produced by these, are very strong due to the flow of material flow. You know that the plastic deformation, there is a condition which known as the strain hardening. So in the strain, you basically deform it to reach into the strain hardened zone, and you know that in the strain hardened zone, your material acquires the required strength. Here you can see that the gear rolling produces the gears of higher surface finish, accuracy, and a very high strength. Another process which is called powder metallurgy. So we have already studied what is the powder metallurgy process. So in powder metallurgy process, you take the raw material in the form of powders, and the powders of required compositions are mixed, and during the mixing process, you add certain additives to increase the green density, to increase the flowability into the dye, and to inhibit the agglomeration. And then in this next stage, you fill the required dye of having required shape and size with this powder material, and then you compress it under very high loads. And in the compaction process, you have cold welding, or you can say the plastic deformation of the powder material takes place, and then you have quite compact structure after the compaction stage. And then in the next stage, you try to reduce the porosity and to develop the proper bonding and necking between the powder particles. So for that purpose, you have to heat the powder mass, or you can see the compacted mass, under a specified temperature range that is called the sintering temperature, and it lies in between the 0.7 to 0.9 times the melting point of the material. And in that stage, the pores volumes get reduced and the porosity is reduced, and it leads to the improvement in the mechanical properties. In that particular stage, your material develops the required strength. After the sintering process, you want to reduce the porosity, if you want to improve the density, then you can perform certain secondary operations like repressing, you can perform the impregnation, or you can perform some finishing operations. If you require higher degree or surface finish, then you can go for the machining. So the powder metallurgy is a process which is used to produce near net shaped gears of very high quality, and you can say mainly the spur gears are produced. And sometimes the shearing operation, you can say the sheet metal operation, if you remember that blanking is also done to produce thin gears of metal from thin sheets. From this figure, then there is a die and punch arrangement system. So what you do, you place your thin sheet over the die, and then is allowed to press the sheet, which causes the shearing of the metal. So if you remember the characteristic sheared edge of a sheet in the shearing operation, in the first stage, what happens that initially there is a elastic deformation, then in the second stage there is a plastic deformation, and in the third stage there is a failure of the material, and in the final stage there is a tearing and the separation of the material. So with all the processes going on, you have a blank piece in the form of a gear. So such type of gears are used in watches or in toys. Sometime if you have disassembled your toy or your car, you might have seen very thin gears. So such type of gears are made with the help of blanking operation. Sometimes these gears are also used in some meters, like in dial indicators. So if you open up that dial indicator, you will find that small gears, very thin gears of required precision, they are present in the dial indicators, and they are easily formed with the help of a blanking operation. Then we know that different materials can be used to produce the gears. So one such material is the plastic. So you all know that plastic gears are very light, and they are not used for heavy duties. They are present in toys and electrical equipments, and small to medium sized plastic gears are easily formed with the help of an injection molding machine. So this is the schematic diagram which represents the plastic injection molding operation. So you have a powder feeder, and then you have a barrel. So this barrel is basically heated to a predefined temperature at which the plastic melts, and inside that barrel there is a moving screw which moves at particular RPM, and this can also move back and forth. So what you do, you take the raw material in the form of chips or powders or plastic, then you feed it with the powder feeder, and then all the raw material enters into the barrel, and with the application of this heat, this plastic material is melted into this cavity, and with the movement of this screw rotation, all the material propels forward, and then when it reaches in this region, this smallest region, so what you do is screw can also reciprocate, and then it produces the pressure into this zone, and the molten material is injected into this die cavity, and this die cavity is also having the split dies which are operated, their opening and closing are controlled with the help of this tie rods and movable platen. So this is a very simple diagram of injection molding process in which you prepare the gears of plastic materials, and such gears are used for light loads, and main application is in toys and electrical equipments. So if you like the video, then please subscribe my channel, share it to your friends, and don't forget to hit the bell icon. Thanks for watching my videos.